So I'm here at the Innovation Hub in Port Macquarie at Essential Energy's depot, and behind me is a pretend house of the future. So they're testing things like load and exporting power. They've got a Nissan Leaf here charging. They've got 20 kilowatts of solar, testing things like vehicle to grid and taking houses off grid completely. I'm going to take you inside and chat in more detail with actual experts who know what they're talking about. This is fascinating. This is going to make the grid more resilient and smarter. So let's go check it out. Brad.
Yes, sir.
So you were telling me that there's sort of two sides to this pretend house of the future that we're in.
There is.
This is the load side, is that right?
Correct.
Can we do a little walk around? You can tell me what's happening on this side and then we'll go to the other side.
Sure, we can do that. What would you like to see first?
Show me all your white goods.
Oh, okay.
Show me your white goods.
So we have a smart fridge here, which is temperature controllable, and we temperature change the freezer side of this when we have excess energy. So make this freezer section really, really cold. That helps store the energy into this freezer in a smart way.
Ah, and so you've got a dishwasher.
Correct, and we do the same thing there. We can control that dishwasher for when it operates and how it will operate. So we can pick what cycle we like, and it can turn it on based around what type of energy we're wanting to use at the time.
So this is just a resistive, old school electrical tank, yeah?
Yeah, that's right. It's just a standard electrical hot water system, resistive hot water system, and we can turn that on smartly or turn it off smart as well. So depending on whether we've got excess energy, we can heat our hot water system or turn it off.
What's this down here?
This thing here is a SIG Energy all-in-one device, so it has a inverter in it. It also has a 25 kilowatt DC charger in it and 8 kilowatts of battery.
All in one thing?
Yeah, and you can stack it up to 48 kilowatts worth of battery.
And you were telling me, actually, you said that this has an extinguisher, a fire extinguisher in it, built in, doesn't it?
That's correct. For each battery pack that you put into it, it has its own little fire extinguisher in it, so it avoids battery thermal runaway.
That is bonkers. So you've got two. Okay, you're over the top now. What's here? So what's going on here? Is this?
This one here is a
dryer.
dryer.
Is that two washing machines? Oh, it's a dryer and a washing machine.
And then a washing machine. Yeah.
What do you need two washing machines
and we
for?
can smart turn these things on and off. So think about you're just on your way to work and you think, I'll throw my clothes into my washing machine or my dryer, and then when my solar comes on, I'll turn these things on. That's effectively what we can do here.
So you've got a Nissan Leaf outside, and you were saying you've got 20 kilowatts of solar panels as well.
Correct.
Is this a vehicle to grid, or is this an off-grid house? Like, are you testing both things here?
It's both, really. So for our customers that are on our rather longer feeders that suffer extensive outages, then effectively we're testing solutions that could help support them during outages.
Off-grid, essentially.
That's right.
Right.
Yeah, or then when you're connected to the grid, well, how do you get a return on the assets that you've invested in? So your vehicle, for example, that helps you.
So what's this? What's this?
That's our shower for little people.
What do you mean?
So to simulate...
I'm not that little.
No. To simulate a real life situation, we turn our shower on and off. So let's have a go at putting that on, eh? Yeah. So we just run this as it would be in the real world.
It's steaming, right? There we go.
Straight out of the hot water system.
So in terms of the water efficiency of that shower head, how many wells star rating is it?
It's completely efficient because it gets recycled.
Ah, okay. I didn't get that
So,
right.
Yeah, it's better than wells, really, when you think about it.
That is amazing. So what's this?
Some of our 3D printers for doing stuff that we do here in the lab, so building little test prototypes. And this is quite clearly our pool here.
Wow.
So we simulate a pool. We can run the pool pump up as well. And just like you would have for your swimming pool. So we simulate swimming pool loads, we simulate hot water system loads.
So you really are running energy hungry things that are,
just like your house.
Just like a regular house.
Yep,
okay.
Exactly right.
Can it handle like everything being on at once?
Yes.
There you go. Good.
Sure can. Turn everything on and off at once.
Amazing.
Yep.
What does all this mean?
Well, this is our dashboard at the lab here. It's showing what solar we're generating at the moment.
Okay.
So we're pushing around about 16 kilowatts of solar out. These are our individual loads graphically represented here. So
you've got hot water, dryer, pool pump, shower. Wow, okay, yep.
So we can individually monitor each one of those loads.
Yep.
This is the national electricity spot price. So at the moment it's telling us the price in megawatts for energy on the national electricity market. So just recently we were negative for today.
And what happens when it goes negative? What happens here? What do you do? Anything? Do you take power from the grid?
Yeah, we can simulate, and we do that with some of our appliances. We say respond to a spot price and turn on, for example.
Do you make money here?
No, it's a lab test.
Could you make money here?
We could make money if we decided to.
So what's this one?
This is showing the lab layout. So this is the lab here.
Yep.
Same, we're consuming 21.6 kilowatts. Our solar is generating 19.4 kilowatts at the moment, and we're taking 2.2 from the grid.
And what's this one here then?
That's the vehicle to grid. At the moment, the Nissan Leaf is just on a charge, but we can turn it on and it will discharge into the lab and reduce our consumption.
So is it charging or discharging right now?
At the moment, it's charging, but it's in an idle state because the battery's full.
Gotcha. And so this is just your sort of total numbers?
Yeah, that's correct, yeah.
And then what's going on up here with your energy consumption?
This pie chart's just showing what assets are on at the moment and what sort of energy they're consuming. So at the moment, our hot water system's heating up, and that's at 3.3 kilowatts, which is this larger portion.
That's using a lot of power, isn't it?
Yes. We just ran it a few minutes ago, so it's got got into heating.
And if that was a hot water heat pump, then that would be using less energy, correct?
That's correct, but over a longer period of time as well. Yeah, exactly right.
And then this is your forecast with knowing when to turn everything on or...
That's right. So we can write some algorithms based around weather forecasts as to what assets we might turn on or off, whether that's export or import energy.
This is Suzanne from Essential Energy. So what are you going to show me right now?
Basically, I think Brad has shown you all of the white goods, etc. And this pretty much shows you how it all hangs together, how we can optimize usage of all of this.
Yeah. Kitchen, laundry, lights, climate, EV chargers, and you can control it all from this spot.
Yes, so we use a product called Home Assistant, which is open source. We're trying to go down the open source road because it's free. Everyone can use it. I use it at my house, actually. And it's highly customizable. So all of these appliances that you can see are linked into here. So which room would you like to have a look at?
Lights.
Lights? Okay.
It's not a room.
It's not a room.
But it's lights. We can see it.
It's lights, yeah. So we can control all of the lights on top of us. So change the lights. There we go. And people always think this stuff is quite expensive, but I think these lights were around $14 per pop. So all of this stuff is actually quite affordable.
So this is all off-the-shelf stuff that you've bought to set all of this up. Is that right?
Yes.
Except the 3D printer.
Except the 3D printer. And with the white goods, we have done sort of a mixture between, they're all sort of mid-grade price range, but there's also quite cheap products, which we have amended slightly to make work. So literally just an on and off scenario, but you can also, other appliances you can control. For example, the fridge, it's not just an on and off, it's the temperatures within the freezer. Basically, the biggest thing, even for me at home, I can see how much energy I produce at the minute from my solar system, and I can make informed decisions. Do I want to put my dishwasher on? Do I want to put my washing machine on, etc.? So it all becomes about energy optimization. So I'm producing free energy, and I want to consume as much as possible of that free energy, because that's going to make the most difference to my pocket.
Do you feel like people are already quite primed for that because we have solar on our roofs, and you have your solar app, and you're already looking, going, the sun's shining, I'll quickly go and turn everything on?
I think we need a bit of change in that space, because I think we've come from a world where exports were quite heavily promoted. Export as much as you can to make some money. That's going away more and more, and self-consumption really should be the priority.
Use what you're producing.
As much as you can use it, that's how you're going to save the most money.
Especially with, how will that change when people have home batteries as well?
That's another level of complexity again, because then you're almost self-sufficient. So you can produce your power, and it can feed your battery, it can feed your electric car, all of the things in here. And this will really become important. How do you manage all of that? And there's lots of smarts behind it. You can say, I don't care what you do, I just don't want to pay money, and I want my EV charged to 80% by 6 a.m. in the morning.
So there's already chargers on the market, aren't there, that will do that for you?
Yes, but you're almost becoming your own little energy ecosystem, and just need to work out what works best for you.
So is this really a little microcosm of the future in that we're decentralizing the grid?
Yeah, absolutely.
Well, thank you, Suzanne, very much for speaking to me.
You're
because
welcome.
I really have no idea what's going on, but that's amazing, and I got to play with lights, so that's a very good thing. And look at that, EV chargers, metered data, lounge room office. I think this is the future. Actually, I do know what these are. So these are inverters. So tell me about this. This is where you're testing the exporting, is that right?
That's correct, yeah. So what we're doing here is making sure that inverters that are being put out on the network meet standards that we need as a requirement for Electricity Authority.
Yeah.
And we're also trying to dynamically talk to these inverters to alter the exports when the network can accommodate it.
And you were telling me about how these are limited, is that right, in terms of how much you can export?
Yeah, in most of Australia at the moment, when you purchase a solar system, the Distribution Authority will set an export limit to try and protect the network. And that export limit might be lower than your capacity. So let's say you've got a 10 kilowatt inverter system, then your export limit might be 5. That extra 5 kilowatts you might be able to generate just gets burnt away as heat.
Right. And do you test like being able to push more energy out than that?
Yeah, that's right. So what we're testing here at our facility is if we can dynamically talk to that inverter and alter the export limit when the network can accommodate it, you can put more energy back onto the grid and get a return on that investment, and the cost of that energy is zero.
So we've just passed the vehicle to grid legislation, haven't we, in terms of allowing that to go ahead. What do you foresee in terms of what's going to happen in maybe the next 5 years?
Yeah, I think we'll see a massive uptake of vehicle-to-grid technology over the next 5 years, and that will bring more flexibility to customers about when and how they want to consume their energy, and probably more to the point about where they get financially rewarded or may choose to pay for energy based on where it is located.
Right. Do you think electric vehicles are a big part of this mix?
Yeah, totally. Without electric vehicles as part of the renewable energy mix outcome in Australia, I think that the grid will inevitably become much more costly and more unstable.
You were saying to me that these do different things along here. Can you explain that to me a bit more? So you've got inverters here.
Yes, that's correct.
But this one says pole top batteries.
Yes. So,
and then you've also got vehicle to grid and a 3-phase car charger. So there's lots going on here.
That's right. So we supply off the back of the lab here and monitor for our test facility. We saw the pole top battery before, so we can control that pole top battery being where it's supplied from within the grid here.
Right.
And similarly for our vehicle to grid outcomes and charges, this is the panel that looks after those. We can just decide to supply it from the depot supply or from what we call a variac. A variac allows us to alter the voltage.
Okay.
Yeah, so more like that's the torture path for these things.
And what about this one with your 3-phase car charger?
Yeah,
What's
that's
going on
right.
here?
So this is just a single direction charging vehicle chargers, should say, we have outside, and this just allows us to again power them and also stress test them with different voltage limits. Same outcome, normal depot supply or off the variac, which allows us to change the voltage.
So there's a charger I saw go on the market recently that's a vehicle to grid ready charger. Will you be testing something like that here?
Yeah, and we do. We have one vehicle to grid charger at the moment on test.
There you go. Well, thank you so much. This is absolutely amazing. I think the shower test was my favourite bit. Look, we've got a battery here as well.
Yeah.
What's that one?
That's
SunGrow.
a SunGrow 9.3 kilowatt battery.
So why do you have two different batteries here?
So this one here is what we call a hybrid system.
Right.
So it talks to the inverter there up on the wall.
SunGrow, yeah.
Yeah, that's right. And it's a slightly different architecture to the other battery we just saw before.
Right.
So the other battery is a full DC coupled style battery.
Right. I'm just so happy that there's very smart people basically making our grid smarter and more resilient. So thank you very much.
You're welcome. Thank you.